Next, mathematical statement of the first class. Mathematical statement of the first class. So, ரொம்ப important, நல்ல காரியம். சரி. இப்போ during the compression of gas, இப்போ வந்து கேஸை கம்ப்ரஸ் பண்ணுறோம். அப்போ work is done on the system by the surrounding. So, during the compression of gas, work is done on the system. System மேல ஒர்க் நிகழ்த்தப்படுகிறது by the surrounding. அப்போ ஃபார்முலா delta U equal to Q plus W. Qங்கிறது heat absorbed, W work is done on the system by the surrounding. இது during compression. Okay. Remember, during expansion of gas, expansion போது delta U equal to Q minus W. Expansion work is done by the system to the surrounding. அதனால தான் W வந்து மைனஸ் வரும் during the expansion. Work is done on the system during the compression. So W வந்து பாசிட்டிவ். சரியா? இப்போ நம்ம என்ன பண்ணலாம்னா consider only expansion one. நம்ம expansion work மட்டும் கன்சிடர் பண்ணணும். நல்லா கவனிங்க. consider expansion one. இப்போ delta U equal to என்னது? Q minus W. Expansion work மட்டும் கன்சிடர் பண்ணலாம். Case 1, that is for a cyclic process involving isothermal expansion of ideal gas. Around first case, cyclic process involving isothermal expansion of ideal gas. So during cyclic process, the change in the internal energy is 0. அப்போ என்ன வரும் சொல்லுங்க? delta U equal to சொல்லுங்க Q minus W, that's equal to 0, or Q equal to W வரும். இது cyclic process involving isothermal expansion of ideal gas. Okay, சரி. இப்போ case 2 பாருங்க. ரெண்டாவது for isochloric process. Isochloric process la volume delta V, change in the volume is 0. Volume is constant. So volume வந்து கான்ஸ்டன்டா இருக்கும் அந்த isochloric la. So change in the volume delta V is 0. We know delta U equal to Q minus W. Delta U equal to Q minus the expansion work, that's equal to P delta V. For isochloric process, delta V equal to 0. Yeah? About delta U equal to Q minus 0, that's equal to Q. About for isochloric process, the change in the internal energy is equal to heat absorbed, is equal to heat supplied to the system. So the change in the internal energy is equal to heat supplied to the system. Okay, clear? Right. Next, in adiabatic process, third. Case 3. In adiabatic process, Q equal to 0. Now, no change in heat. Q வந்து 0. இதுல in adiabatic process Q equal to 0. About delta U equal to Q minus W, or delta U equal to 0 minus W, or delta U equal to minus W. About in adiabatic process, the change in the internal energy is equal to work done by the system. Is equal to work done by the system. Next, fourth one, in isobaric process. In isobaric, pressure is constant. Pressure kept constant. About delta U equal to Q minus W, delta E equal to Q minus P delta V. சரியா? So pressure வந்து kept constant. அப்போ in isobaric process நல்லா கவனிக்கணும், part of the heat ஒரு பகுதி heat வந்து used for expansion work. The part of the heat வந்து used for expansion work. The remaining is added to the change in the internal energy of the system. Which is வந்து added to the change in the internal energy of the system. So இந்த நாலு கேஸும் சொல்லிடுறேன். மேத்தமேட்டிக்கல் ஸ்டேட்மெண்ட் ஆஃப் ஃபர்ஸ்ட் லா, கன்சிடர் எக்ஸ்பான்ஷன் ஒர்க். எக்ஸ்பான்ஷன் ஒர்க்கில் டெல்டா யூ ஈக்குவல் டு கியூ மைனஸ் டபிள்யூ. கியூனாக்கா heat absorbed by the system, W na work is done by the system. So first case, cycling process involving isothermal expansion of ideal gas. Appo change in the internal energy zero. Appo Q minus W equal to 0, Q equal to W. For isochloric process, volume change in the, there is no change in the volume. Appo delta V equal to 0. Appo delta U equal to Q minus W. Delta E equal to Q minus P delta V. This is the expansion one. So it is 0 here, delta V. So total is 0 here. Delta E equal to Q. Above, the change in the internal energy is equal to heat supply to the system. Next case 3. In adiabatic process, Q equal to 0. Above delta E equal to 0 minus W. Above delta U change in the internal energy is equal to work done by the system. In isobaric process, delta U equal to Q minus W. Isobaric pressure kept constant, so delta U equal to Q minus P delta V. So a part of the heat used to do PV expansion work, okay, so yeah, remaining is added to the internal energy of the system. Okay, next topic, enthalpy. Next enthalpy. Nalla gavani. Listen, enthalpy. It's a very important topic. Got it. Enthalpy is a thermodynamic property of the system. The thermodynamic property. It is defined as the sum of the internal energy and product of the pressure and volume. This is the enthalpy definition. Enthalpy is thermodynamic property of the system. It is defined as the sum of the internal energy plus product of the pressure and volume of the system. Okay, it reflects the capacity to do mechanical work. Either reflect capacity to do mechanical work or capacity to release heat by the system. It reflects the capacity to do mechanical work or capacity to release heat by the system. When the process occurs at the constant pressure, constant pressure heat involved. Constant pressure process, heat involved, that is either release or absorb. Heat involved is equal to change in the enthalpy. Change in the enthalpy. If the process takes place at the constant pressure. At constant pressure, heat involved equal to change in the enthalpy. Next, enthalpy is state function. It depends upon the state function. Temperature, next state, pressure, water. It is the state function. Next, enthalpy usually represented as change in the enthalpy. Enthalpy usually represented as change in the enthalpy. It is equal to delta U plus P into delta V. Enthalpy usually represented as change in the enthalpy. Change in the enthalpy for a process between initial state to final state. Okay, the change in the usually enthalpy is represented as a change in the enthalpy for a process from initial state to final state at a constant pressure. Okay, because the change in the pressure, listen, the change in the enthalpy. The change in the enthalpy is equal to heat supplied to the system at a constant pressure. தெரியும். அதாவது என்ன சொல்லுங்க? The change in the enthalpy ங்கிறது at a constant pressure is equal to heat supplied to the system at a constant pressure. Okay. சரி. இப்போ in an endothermic process, இப்போ endothermicல heat is supplied to the system. heat நம்ம கொடுப்போம். அப்போ delta P ங்கிறது greater than 0, Q is equal to greater than 0. இப்போ at a அதாவது in a endothermic process heat is supplied to system, Q வந்து greater than 0 or Q உள்ள போடுங்க. So delta H is also greater than 0. So delta H is positive. அதே in endothermic reaction Q வந்து less than 0. இதாவது endothermic exothermic sorry. In endothermic heat is supplied to system. In exothermic Q வந்து less than 0. Heat is released by the system. அப்போ delta H less than 0 இருக்கும். So delta H negative sign ஆகும். So இது ஓரளவு நீங்க தெரிஞ்சினா போதும். So இதுல ஓரளவு இப்போ enthalpy ங்கிறது it is a thermodynamic property of system. It is equal to the sum of the internal energy and the product of the pressure and volume. Okay. Next முக்கியமான பாயிண்ட் சொன்னாக்க constant pressure ல heat involved either absorbed or released is equal to the change in the enthalpy. Clear? Next, the enthalpy is a state function, depends upon the state function, temperature, pressure and volume. Next, enthalpy usually represented as a change in the enthalpy of the system from initial to final state at a constant pressure. Okay, about the enthalpy change that enthalpy usually நம்ம என்ன பண்றோம் change in the enthalpy தான் நம்ம குறிக்கிறோம். இப்போ delta X equal to delta U plus P delta V. சரியா? The enthalpy change at a constant pressure that is equal to heat supplied to the system at a constant pressure. சரியா? Enthalpy change is heat supplied to the system at a constant pressure. If heat in endothermic process Q greater than 0, அப்போ delta X greater than 0, delta X positive. In exothermic reaction Q is less than 0, delta X less than 0, delta X is negative. Okay. Next, you will get up for the very important 5 mark question. Relation is very important. Relationship between enthalpy and internal energy. இப்படி போட்டுக்கலாமா? ரெண்டு பாட்டு இதே முடிச்சு. சரி, இப்போ ஒரு சிஸ்டம் இருக்கு. when a system at a constant pressure changes from initial state ல இருந்து சேஞ்ச் ஆகுது. which initial state ல enthalpy H1, internal energy U1, volume V1. constant pressure changes to final state with enthalpy H2, internal energy U2, volume V2. புரியுதா? Consider a system at a constant pressure changes from initial state with H1 enthalpy, internal energy, volume V1 to final state enthalpy H2, U2 internal energy, V2 volume. Okay. The change in enthalpy calculated as follows. எப்படி கால்குலேட் பண்ண போறோம்னா நமக்கு தெரியும் H என்ன ஃபார்முலா U plus P1 PV. So for initial state என்ன வரும் X1 equal to U1 plus PV இல்லையா PV1. This is equation number 1. Pressure is constant. X2 equal to U2 plus PV2. This is equation number 2. About change in the enthalpy delta H எப்படி கண்டுபிடிக்கிறதுனா from 2 minus 1 இப்போ ரெண்டுல இருந்து ஒண்ணு கழிச்சினா delta H கிடைக்கும். So delta H is equal to 2 minus 1 போடலாமா? H2 minus H1 கிடைக்கும். U2 minus U1 இதில take P common போடலாமா? V2 minus V1. So H2 minus H1 now change in the enthalpy. This is change in the internal energy plus P into change in the volume. இது equation number 3 வச்சுக்கலாமா? சரியா போகுது. சரி, இது வரைக்கும் புரிஞ்சுதா? change in the enthalpy ங்கிறது delta U plus P into delta V. This is U. This is V. சரி, நெக்ஸ்ட் கவனிக்கணும். as per the first law. இப்போ first law தெரியும். first law பிரகாரம் சொல்லுங்க. for expansion working எப்படி இருக்கு? for first law U equal to Q minus W. or delta U கூட சொல்லுங்க. the change in the internal energy is equal to Q minus W. இது வந்து for first law for expansion work. Okay, we know Q equal to P into delta V. That is work is done by the system. Work is done by the system. அதான் வந்து minus W. புரியா? clear? அப்போ delta U equal to என்ன வரும் பாருங்க, Q minus work என்ன போடுவோம், P delta V. This is P delta V. Substitute delta U value in this equation, delta X equation. அப்போ delta X is equal to Q minus P delta V plus P delta V. இது ரெண்டு கேன்சல் ஆகுமா? So delta X is equal to Q P. This is equation number 3. இது clear இந்த பாயிண்ட் சொல்லிட்டா? We know according to first law of thermodynamics, delta U ங்கிறது Q minus W. W expansion work என்னது? P delta V. Okay, அப்போ delta U னா Q minus P delta V. Okay, substitute this in the delta X equation. about Lx equal to Q minus P delta V plus P delta V ரெண்டு கேன்சல் ஆயிடும். So delta X equal to QP. This is heat absorbed at a constant pressure. அதாவது heat content of the system சொல்லுவோம். heat absorbed at a constant pressure ல, சரியா? அதாவது heat content எதுக்கு ஈக்குவலா இருக்கும்? It is equal to the change in the enthalpy. Change in the enthalpy. Because consider here ஒரு closed system of gas. Yeah, consider பண்ணுங்க. ஒரு closed system of gas which are chemically react to form a gaseous product. ஒரு closed system of gas consider பண்ணுங்க. அது react ஆயிட்டு to form என்ன form ஆகுது? gaseous product கொடுக்குது at constant temperature and pressure. constant temperature and pressure. சரியா? இப்போ VI னு வெச்சுக்கோ. VI னா initial volume of the reactant. Okay, initial volume or total volume னு சொல்லுங்க. total volume of the reactants. VF னா total வந்து total volume of reactants. This is total volume of the products. Okay, அதே மாதிரி NI னா number of the moles of the gaseous reactants. Okay, number of moles of gaseous reactants. அதே மாதிரி NR னா number of moles of the gaseous products. number of the moles of the gaseous product. சரியா? We know ideal gasification. தெரியுமா என்னது? PV equal to nRT. அப்போ PV நல்லா கவனிங்க. I equal to PVI initial state ல, சரியா? இதோட PVI equal to NIRT. this equation number 4. அதே மாதிரி PVF equal to இது initial final. இதோட NF RT. this equation number 5. சரியா? இப்போ 5 minus 4 போடுங்க. காமன் எடுத்துலாம் செப்பரேட் பண்ணுங்க. காமனா P எடுத்துலாம். so P into VF minus VI equal to take RT common NF minus NI or P delta V change in the volume is equal to RT delta NG gas. Okay, so இப்போ இத வந்து இதல போடணும். substitute in this equation, delta X equation. so we get finally del X ங்கிறது delta U plus RT delta NG. is very important 5 mark question கேட்கலாம். சரியா? இப்போ once again நான் உங்களுக்கு clear சொல்லிறேன். derive the relationship between enthalpy and internal energy. consider a system at a constant pressure level changes from initial state to final state. initial state la enthalpy H1, internal energy U1, volume V1. final state la enthalpy H2, internal energy U2, volume V2. the change in the enthalpy calculated as follows. X equal to U plus V நமக்கு தெரியும். x1 வந்து என்ன u1 plus pv1 x2 u2 plus pv2 2 minus 1 போட என்ன வரும் x2 minus x1 equal to u2 minus v1 that's இது வந்து p காமன் எடுத்தோம்னா p into v2 minus v1 del x equal to del u plus p delta v. Okay, we know according to the first of thermodynamics for expansion work delta u equal to q minus w. q ங்கிறது heat supplied to the system, w na work is done by the system and the work வந்து என்ன work expansion work p delta v. So delta u equal to q minus q delta v. Substitute பண்ணினாக்க equal to delta x equal to qp. சரியா? So heat supplied to a system at a constant pressure is equal to the change in the enthalpy. Because consider here closed system of a gaseous reactor. Okay, closed system of the gases which are chemically react to form a gaseous product at constant temperature and pressure. V is the total volume of the reactor. V is the total volume of the product. N is number of the moles of the gas in the reactor. N NF is enough. NF number of the moles of the gas products. So we know according to the ideal gasification PVA equal to NaRT, PVF equal to NFRT. பாஞ்சிலிருந்து நாலு கேஸ்னா P காமன் எடுத்தா VF minus V equal to RT NF minus Na. So P del V equal to RT delta NV. Substitute this equation. Substitute in del H. So we get del H equal to delta U plus RT delta NV. Okay, thanks. இப்போ ஒரு ப்ராப்ளம் போட்டுடலாம். ஓகே, எக்ஸாம்பிள் ப்ராப்ளம். இப்போ a gas contained in a cylinder fitted with frictionless piston. Okay, expander, the gas expands against constant pressure 1 atmosphere. Constant pressure gas is expanded from a volume of 5 liter to 10 liter. Gas was expanded from volume of 5 liter to 10 liter. During it absorbs 400 joule of thermal energy. Your energy absorb. Okay, can determine the change in the internal energy. Question again. Determine change in the internal energy. நம்ம ஏற்கனவே பார்த்துருக்கோம், சொல்லியிருக்கோம். சரியா? இதில் பார்த்தீங்கன்னா at a constant pressure change in the internal energy என்ன formula for expansion work Q minus W, that is delta E equal to Q minus P delta. So Q ங்கிறது எவ்வளவு 400 joule, pressure வந்து எவ்வளவு 1 atmosphere, change in the volume எவ்வளவு 10 5 இருந்து 10 இல்லையா? அப்போ initial volume 5 final 10. அப்போ change in the volume 10 minus 5 liter. This is return. Okay, இப்போ substitute பண்ணலாமா? அப்போ change in internal energy equal to 400 joule minus 1 atmosphere into 10 minus 5 liter. That's equal to 400 joule minus என்ன வரும் 5 atmosphere liter. சரி, இப்போ நல்லா கவனிக்கணும். 1 liter atmosphere equal to 101.33 joule. எவ்வளவு joule? hours. இது மல்டிப்ளை பண்ணலாமா? So delta U equal to 400 joule minus 5 into 101.33. That's equal to 400 joule minus 506.65 joule, nothing but 106.65 joule. Okay, so இந்த மாதிரி क्वेश्चंस எல்லாம் ஈவன் நீங்க கூட கேட்கலாம். ஓகே, கிளியரா? Thank you.